Exploit Bash vulnerability CVE 2014-6271, also known as ShellShock. All right, so we're now getting started with the Linux exploitation section of this course. And the first vulnerability that we're going to be exploring is the ShellShock vulnerability. Now, the interesting thing about this vulnerability is it was probably one of the biggest vulnerabilities that affected Linux over the last, I would say, over the last 15 to 20 years, and for good reason, right? And again, the reason that makes this vulnerability, so dangerous or, critical in regards to a Linux system is the fact that it essentially allows an attacker to remotely execute arbitrary commands on the Linux target. And the exploitation of this vulnerability really involves two services. One of them is Apache, and the second one, of course, is Bash. All right, so let's learn more about this vulnerability. ShellShock is the name given to a family of vulnerabilities in the Bash shell since version 1.3, which was released, I think, somewhere in the 90s. So again, it really affected a huge number of Bash versions, after version 1.3. So this vulnerability essentially allows an attacker to execute remote arbitrary commands via Bash, consequently allowing the attacker to obtain remote access to the target via a reversed shell. And that's where it primarily gets its name from. So, ShellShock, that tells you that in there somewhere, or rather this vulnerability allows an attacker to get a shell on the target system. The ShellShock vulnerability was discovered by Stefan Chazelas, I hope I'm not mispronouncing that, on the 12th of September 2014, and was made public on the 24th of September 2014. So again, given the actual critical nature of this vulnerability, patches were released soon after, and of course, companies and organizations as well as individuals were actually informed to update their versions of Bash as soon as possible. However, given the current fragmented nature of the Linux world and the various distributions available out there, the patching or the updated packages stories based on the actual distributions the actual release cycle, right? So if a distribution had a slower release cycle, maybe after every 6 months, then packages could those distributions could actually be releasing the updated patches for Bash very, very late. However, you had the ability to update it manually, and that's one of the great things about Linux. This vulnerability really isn't very common anymore, but it's very important that you actually learn about it and get an idea as to how to exploit it. And this will really tie into the web application penetration testing course on INE, as well as the EWPT certification. So learning about command injection in this case is very, very important. Now, what is Bash? If you've ever used Linux before, Bash is essentially a Nix shell. Nix is essentially an abbreviation for Unix-based, operating systems, and Linux is a Unix-based operating system. So Bash is a Nix shell that is part of the GNU project and is the default shell for most Linux distributions. So whenever you install really any distribution, Ubuntu, Debian, Arch Linux, Fedora, by default, the default shell is going to be Bash. All right. Now, what is a shell? Well, a shell is essentially a command line interface. So on Windows, you have your command prompt, and on Linux, you have your various shells. And Bash is the de facto standard for most distributions. So again, this vulnerability really did shake up the whole Linux industry in regards to vulnerabilities, right? Now, the ShellShock vulnerability is caused by a vulnerability in Bash whereby Bash mistakenly executes trailing commands after a series of characters, and these characters are really down to the fact that there is a vulnerability within Bash in regards to the environment variable function declaration. Now, I won't get into the actual nitty-gritty of this vulnerability and how it works. All that you need to know is that if these characters are input into Bash, really any other commands executed after these special characters will be executed by Bash. Now, again, given the fact that this vulnerability primarily or really exclusively affects Bash, the vulnerability really only affects Linux, as Windows does not utilize Bash, as it is not a Nix-based operating system. So this vulnerability really was pertinent only to the Linux operating system, right? Now, in the context of remote exploitation, Apache web servers can be configured to run CGI scripts or shell scripts that are vulnerable to this attack. All right, and you might be asking yourself, well, I'm not really understanding what's going on here. You're saying the vulnerability is related to Bash, or it's a vulnerability within Bash, but how does that tie into CGI scripts? Well, CGI, which stands for Common Gateway Interface, CGI scripts are used by Apache to execute arbitrary commands on the Linux system, after which the output is displayed to the client. So if you're running a web server, an Apache web server, and you're hosting a web application, regardless of whether it's PHP or HTML or anything like that, you can create or develop CGI scripts to essentially obtain information from the system. So for example, if I wanted to get the current time on the Linux server, I could use a CGI script to essentially execute the time command and then redirect or display the output on the actual website or the web page. So again, many web servers or many websites actually utilize this functionality to limiting to varying degrees, and again, you don't see it anymore now for obvious reasons, primarily because if the attacker is able to execute the CGI script, and in the case of this vulnerability, pass in this special set of characters as well as additional commands that you would like to execute, he could potentially use this vulnerability to execute arbitrary commands that could be malicious. Right, so CGI scripts are used quite a bit on Apache, and they're very, very useful. And of course, you'll see exactly how they're used during the practical demonstration. So coming down to the actual exploitation of this vulnerability, in order to exploit this vulnerability, you will need to locate an input vector or script that allows you to communicate with Bash. That's really the crux of this vulnerability. Now, in the context of an Apache web server, we can utilize any legitimate CGI scripts accessible on the web server. And because they're interacting with Bash or getting Bash to execute some commands, we can utilize or send a request with this particular CGI script and get those special characters inputted, as well as any other commands that we would like to execute. So whenever a CGI script is executed, the web server will initiate a new process and run the CGI script with Bash. So whenever we make an HTTP request for that particular CGI script, the web server will initiate a new process and run the CGI script with Bash. So we can essentially input these special characters that I highlighted in the previous slide within one of the HTTP headers. The most effective technique is to actually input those or inject those parameters or characters within the user agent HTTP header, and then specify the other commands that we would like to execute after those characters. So in terms of exploitation, as I said, we can do this both manually and automatically. Manually, this can be done really easily by the use of a proxy. So we can use the burp proxy. And in terms of automating this particular attack, we can also utilize an MSF exploit module. And in both cases, I'll be showing you how to obtain a reverse shell or a Meterpreter session, respectively. All right, so now that we have an idea as to what this vulnerability is and how it can be exploited, let's get started with the practical demonstration side of this video. And this video already has a lab environment attached to it, so you can start it up and you can follow along with the techniques. So I'm going to start up my lab environment and I'll see you within the lab environment. All right, so I'm back within the lab environment, and in this case, you will not be provided with the target IP, but that can easily be obtained by opening up your terminal. I'm just going to open that up and maximize this so you can see what's going on. If you type in ifconfig and take a look at the interface Ethernet 1, this is your IP address here, or the IP address of the Kali Linux system. The target IP address is going to be the next IP address within this subnet. And of course, in your case, the subnet is going to be different. All you need to do is just change the 2 to a 3, and that's the target IP. So we'll just copy that there. And I'm going to perform an Nmap scan on the target to identify whether we have an Apache web server running. So I'm going to say Nmap, and we'll perform a service version detection scan. And I'll paste in the target IP. So I'll change the 2 to a 3, and I'll hit enter. And I'll give this a couple of seconds to complete. All right, so the Nmap scan is complete. And as you can see on port 80, the target is running an Apache web server. Right, so we can actually confirm that. I'm just going to copy the target IP right over here. I'm going to open up my browser and let's actually confirm whether we have a website or a web server running. So there we are. I'll hit enter. And as you can see, let me just maximize this. You can see that the website is currently under construction. However, if you pay close attention, there's a piece of text here that doesn't look to be rendered in HTML or doesn't seem to have any CSS attributes associated with it. And this essentially tells us that the website will be online in 0 days, 23 hours, and 57 minutes. Really, really cool, right? But how is this being done? Because it looks like it's very dynamic and it's being done on the server side. Well, this is being accomplished through the use of a CGI script. So if we view the actual source of this page and take a look at where that particular output is being displayed, you can see there's some JavaScript here. And we can see that it actually executes a CGI script called gettime.cgi. And the CGI script is stored in the root of the web server, which means we can access it. It's publicly accessible. So we can say gettime.cgi. All right. So, and you can see it just displays the actual information that we got on the website. And that means that the web server has a CGI script that we can use. And again, this CGI script is passing in commands to bash, or is executing commands with bash. And what we can do is utilize this as our input vector. However, we also need to check as to whether this particular server or whether this particular system is vulnerable to the ShellShock attack or vulnerability. And that can easily be done with nmap. And the way we can do that is by saying nmap and then utilizing an nmap script. So I'm going to say nmap and we're going to perform service version detection scan. I'll paste in the target IP. We're going to say script equals, and in this case, we're using the ShellShock script. So ShellShock, and the actual name here is HTTP ShellShock. There we are. And then we need to specify the script arguments. And the script arguments for this particular script are essentially utilized to specify where, or the actual CGI script that we're testing, right? So I'm going to say script arguments. And then in double quotes, I'm going to say HTTP. And these are the script arguments. So HTTP ShellShock. There we are. And then we specify shellshock.uri to specify the actual URI of the CGI script. In this case, the CGI script is under the root of the web server, and the name is gettime.cgi, right? And we can then close the actual quotation there, and we can hit enter. And I'm just going to wait for this to complete. All right, the nmap script scan is complete, and as you can see, it gives us the basic information we got previously. However, the output for the HTTP ShellShock script tells us that this target is vulnerable. So you can see HTTP ShellShock vulnerability state is vulnerable and exploitable. It provides you with the actual CVE right over here. And this web application might be affected by the vulnerability known as ShellShock. It seems the server is executing commands injected via malicious HTTP headers. All right, so that means we can utilize the CGI script and inject, our own. We can essentially inject the actual characters, the special characters within HTTP headers. And in this case, we will be injecting them in the actual user agent header. So in order to do this, what we're going to do is we are going to open up the burp proxy. But before we do that, this particular lab environment has Mozilla Firefox already configured with Foxy Proxy, which is a plugin that allows you to automatically switch between proxies. And a Burp Suite profile has already been created for you. So just click on that there. That means that all traffic will be redirected to the Burp proxy. We can then open up Burp Suite by clicking on the Kali menu and heading over to Web Application Analysis and Burp Suite. And we'll give this a couple of seconds to start up. This is a temporary project. Next, we're just going to use the default configuration. And we're going to give this a couple of seconds to start up. All right. Disregard the actual message there, and we're going to click on proxy and make sure that intercept is set to on. I'm just going to forward these requests here, and then we can request or make a get request for the gettime.cgi script. So I'm going to say reload, and you can see it's going to be intercepted within the proxy. And as I said, we are going to be injecting the special characters in the user agent HTTP header. In order to do this, we can send this particular request to the repeater. And I'll then click on the repeater tab, and we can get rid of the user agent information here, and we can replace that with our own with the special characters. And in order to do this, we're just going to paste or type them in. So we start off with 2 brackets, and we then have curly braces. And within the curly braces, we are going to, specify that we want a colon and semicolon. And then we're going to close the curly braces. And we're then going to, specify another semicolon. And then we're going to say echo. I'm just going to type that in correctly. So echo and echo again. So echo semicolon, echo semicolon. And then we can execute our own command. So we can say bin bash C. And in this case, let's try and print out the contents of the password file on the Linux system. Of course, you can execute other commands. So I'll just say cat etc password, and let's see whether we can enumerate that information and test whether this actually works. So to actually send that request with the repeater, let me just expand the window here. We can just say send, and you can see that this will actually display the output of that command. So I'm just going to open up burp again here. And there we are. So you can see that we specify we wanted to access the contents of the file cat etc password, and you can see that is executed and we get the output right over here. So the password file on Linux essentially contains a list of all user accounts. So it looks like we have a syslog account, a nobody account, as well as a backup account and the root account right over there. All right, so that essentially verifies that this vulnerability does indeed work. Now, what if we wanted to gain a reverse shell on the target system? How would we go about doing that? Well, we can utilize bash to essentially connect to a listener on our Kali Linux system. So in order to do that, we're going to set up a listener with netcat. So I'm going to say netcat nvlp, and I'm going to listen on port 1234. I'm going to hit enter, and it's going to listen on that port for the connection when it is executed, right? Or when a connection is made from the target system. I'm then going to open up Burp Suite. And within this particular, within the request field here, and let me see if I can actually zoom in here. So burp, I'm just going to zoom in. All right, so I've been able to zoom in so you can actually see what's going on here. And you can see that this was the command that we specified earlier on. And what we're going to do is we are just going to replace this particular command here because we are going to be connecting with bash to our listener. And in order to do this, we are going to say bash I, right? And we are going to connect. So I'm going to just output this or redirect the output. And we are then going to utilize the dev TCP binary. So dev TCP. And then we need to specify our Kali Linux IP. And remember, in your case, it's going to be different. So I'll open up a new tab here and I'll say ifconfig, and your IP address is going to be the IP attached to the interface Ethernet 1. All right, so I'll go back into burp and I'll paste that in there. And let me just make sure that that is formatted correctly. There we are. And then I need to specify the port that we're connecting to on our Kali Linux system. In this case, it's port 1234. And then we are just going to say 0, redirect the output, and 1. There we are. And we can essentially just hit forward or send. And we should get a reverse shell on our netcat listener, and we do. So you can see we get a connection from the target, and we're currently logged on as the daemon user at victim1. So I can say, who am I? And I can also enumerate the information regarding the distribution. So I can say cat etc issue or cat etc release. So you can see we're running Ubuntu 14.04.6 and uname A. All right, and there we are. So you can see that gives you the kernel information, etc., etc. All right, so that is how to exploit the vulnerability manually using the burp proxy. What we're now going to do is take a look at how to exploit this vulnerability with the Metasploit framework. So I'm just going to open up a new tab here, and we'll start up the PostgreSQL database service. And I'm also going to start up MSF console, and we'll give this a couple of seconds to start up. All right, so that is started up, and we can search for the actual name of the vulnerability. So I can say ShellShock, and we have 2 modules that we can use. First of all, we have the auxiliary module here, and I'm just going to zoom out. So let me just zoom out here so you can actually see that. So we have the auxiliary module, which will tell you whether the target server is vulnerable. And then we have the exploit module right over here. All right. And I'm just going to copy that there, use and paste. All right, so you can see Apache mod CGI bash environment executable or execution, and then we can clear the terminal and show the options here. And in terms of the options that you need to specify, you need to specify the target, or rather the target IP address, as well as the port that the web server is listening on. In this case, it's port 80, so that's fine. So ideally, we only need to specify the target IP, which in this case, I'm just going to copy from my web browser. That is right over here. So I'll just copy that there. And what I'll do is I'll just disable or get rid of Burp Suite right now because we don't need it. There we are. And I'll also disable the burp proxy, so turn off, and you can see we can still request for that CGI script. So I'm going to say set our hosts to the target IP, and I'm just going to get rid of the HTTP option there, and I'll hit enter. And we then need to specify the target URI. That is essentially the path to the CGI script. So I'll say set, and we're going to say target URI. And we're going to set that to getTime.cgi. All right, so once that's configured, I can hit exploit. There we are. It looks like it works, and we get a Meterpreter session on the target system. So again, sysinfo, we'll pretty much get exactly what we got on our reverse shell. So there we are. It's running Ubuntu 14.04. And you now have access to the target system. And of course, the next logical step would be to elevate your privileges, but we'll get there when we get there. So this is going to conclude the practical demonstration side of this video. In the next video, we will be taking a look at how we can exploit FTP, or rather a Linux server running FTP. All right, so I'll see you in the next video.